Okay, good morning. Welcome to
FamilyMath number 456.
FamilyMath 456. So today we're going to return to a book we've only looked at once before. It's this book called Why Not by Colin Adams. And Colin Adams is a math professor at Williams, which is a college in western Massachusetts.
Okay.
And so we're not going to go do a deep dive into knots today. We're just going to talk about three interesting properties of how mathematicians have been able to talk about knots and then also links. Actually, we're going to start with links. The difference between a link and a knot is a link has multiple parts, I think, and a knot would just be one continuous loop, but still can be very complicated. So the first question we're going to study is, are these two things the same? Two rings that are not connected with each other, and two rings that are, I guess, linked together.
Well, I don't. They're the same two shapes, but I don't think they're the same because you can't pull these apart, and these can move anywhere.
All right. Do you think these should be the same?
No, because
Why not?
you can't put these together without cutting them open and then pushing them shut again
Okay.
to make this.
All right. Interesting. And so how do we turn that into a math problem? It's tricky, huh? This doesn't seem like a situation necessarily that math is going to be all that useful for.
Yeah.
Right?
Yeah.
And so that's kind of one of the fun things about knot theory is mathematicians have made an enormous progress in learning about knots and studying knots and finding what different kinds of knots and links there are.
Yeah.
And one of the most difficult questions is how do you tell when two things are the same or when two things are different? So what might you be able to do here, for example?
Well,
How could two things not look the same and be the same?
Well, like you could say,
maybe
square root of 4 and 2. They don't look the same, but they are the same.
Oh, that's a great example. Yeah. Maybe this is the equivalent of the square root of 4, and this is 2, and it's two different representations of the same thing. Or maybe it's really different. Maybe this is the square root of 5, and this is 2.
Yeah.
So, the thing I'm going to explain to you is something called the linking number of a knot. And the way the book talks about it is we can talk about an over cross and an under cross like this
Yeah.
as being worth +1, and an over cross and an under cross like this is being worth -1. And what we'll do is every time we have a crossing,
We can
add up whether we're +1, +2, +3, whatever the number is. And if the numbers for two different shapes are different,
then they are different.
the shapes are actually different. Now, it's not obvious that should be true, by the way. I'm just going to take that as a given,
Yeah.
that's true. That's not obviously true. It might be that you could maneuver these rings around in such a way that you would change this linking number, but this is something that's known as an invariant. So, what do we do with the crossings for this shape?
There's no
10, so
crossings, so it's
start to
equal to
0.
Yeah. And so the only thing we have to do here is orient. So let's say we're going around this way.
Alright.
Okay. Now we'll do the same thing with these two knots. So we're going around this length this way and this length this way. Okay.
Well, let's see. You have
So let's look at this crossing here first.
so you have this part here is going over,
This part is the over part.
and then that other one is the under. So this one is the +1,
This one is a +1.
and then
Okay.
and then as we go along, we
All right.
get to another one.
So this one we said is a +1, and now let's look at this one up here.
Well, again,
That one,
oh, this one is going over. Yeah.
but you're not going that way, you're going this way, right?
Oh, geez. Sorry. You're absolutely right. I goofed. let's back up. My mistake. Thank you. This one's going this way, but this one's going this way. Okay. So now we have a little bit more difficult situation. We have the over going this way and the under going this way. So which one of these two things do I have?
Well, couldn't you flip this one over? And then you'd have the over in the same place, but the under going that way.
Well, I can rotate definitely, but I can't flip.
So, well, but if we rotate, then the over is going to be pointed this way, and the under is going to be pointed down.
Okay, so which one of these two is this situation? Which one of these two can be rotated to be this situation where the over is going this way and the under is going that way?
The other one, this one.
Okay, how do you do it?
You rotate it 90 degrees like this.
Okay.
So
Do you see that?
that would mean, so the over would be going this way, and then the under would be going that way. So that one works.
Okay, good. So my mistake before, that is a -1. And this time up here, we've got the over going this way and the under going that way. And so which one is that?
Under. Well, that would also be a minus. That would also be a -1 too, because you can rotate it down again.
Okay, so this is a -1.
So the value of this shape is -2.
Right, the value of this shape is -2, and
The
what's the
value of
value
that
of this
shape is
shape?
0. So that means these two shapes are different.
And that helps us see that they're different. Okay, so let's go to the next one.
All right.